Hello everyone. Today I am going to discuss something about regression analysis. Before I start my video lecture, I acknowledge the various internet tools for my discussion as well as W3 schools for regression analysis using Python. Before we start using a Python tool for regression analysis, let us understand what is the meaning of a regression analysis, what are the different types of regression analysis, how do we implement these types of regression analysis in Python. So these are the three important discussions for today's video lecture. I begin with the concept of regression analysis. What is regression analysis? It is the estimation of relationships between a dependent variable and one or more independent variables. Basically, when you take certain data from data set, when you're analyzing the data based on the data set, you can use these kind of tools wherein independent variable has some relationship with the dependent variable. Let me take an example, very simple example to prove my discussion. The GDP or the money value, let us say, every currency has got its own value and the value keeps on changing. Suppose if the value of the money goes down, ultimately price in the market hikes. So price in the market, price of any commodity or price of any item in the market is depending upon the value of money. So there is a relationship. There is a relationship. Let me give another example. The availability of the product. I will take a simple product like vegetable. You might have already seen the tomato, the price of tomato has gone up like 100 rupees per kg when the tomato was not available in the market. There is a linear relationship. Whenever the tomato is available in the market, the price has gone down like anything. So, here the very important point to note is it is a relationship. See, I don't give any types here, but in general, I am giving an explanation of what is regression analysis. It is the estimation of relationships between dependent variables. So there should be one dependent variable. As I mentioned, the price of the currency. It's a dependent variable. Why it is a dependent variable means you are tendering the same currency in the market for all purchases. So the price, there is a dependent variable and either one independent variable or more than one independent variables. Now, what type of relationship is being established talks about the types of regression analysis. So, regression analysis is a set of statistical methods used for estimation of relationship between a dependent variable and one or more independent variables. So we have seen the estimation of relationship between dependent variable and one or more independent variables. So analysis here is a set of statistical methods which are used for estimation of such a relationship. Python has several tools for these kind of estimation. So, it is the set of various statistical methods used for the estimation of relationships between a dependent variable and one or more independent variables based on the number of dependent variable, and of course there will be one dependent variable, number of independent variables, and the relationship. The regression analysis has three different types of analysis. One is what is called linear regression. Another one is what is called multiple regression, but normally, strictly speaking, it is multiple linear regression. And third one is non-linear regression. So these are the three categories of the regression analysis. Now let us see what is the meaning of linear model, or how do you define a linear regression analysis. Basically, linear regression analysis is based on six fundamental assumptions. Namely, number one, the dependent and independent variables show a linear relationship between the slope and the intercept. Now, what is a slope and intercept? These two are the concepts which are related to a single straight line. Every line has got a slope. So what is the formula for a line? Line is y is equal to mx plus c, where m is the slope. So it is because linear, the regression here is a linear, the relationship between dependent and independent variables show a linear relationship between the slope and the intercept. First. Second one is the independent variable is not random. It cannot be a random. Why? Because there is a relationship between dependent and independent variable, as the regression analysis says. The fundamental definition of regression analysis says that there is a relationship between uh, dependent as well as independent variables. So, under this linear model of assumptions, independent variable cannot be at random. There will be a formula. We can predict. So, in case of linear regression analysis, we can predict the future variable because it is satisfying the line. So, second assumption is independent variable cannot be at random. Then, third way concept is the residual value or the error value is always zero because the points are near to the line. Error value or the residual value is zero. And the residual value or the error value is constant across all the observations because it is linear. It's constant across all the observations because it is linear. Then the residual values follow normal distribution. Right? So these are the six assumptions which we are supposed to have when we talk about linear regression analysis. So here the simple linear regression follows the equation y is equal to a plus bx plus lambda. So the equation here is y is equal to a plus bx plus epsilon. where y is a dependent variable, x is an independent variable, a is an intercept, b is a slope, epsilon is a residual, which is the error. In case of linear regression, it is 0 always. So, by now you might have already understood the concept of linear regression. What it is? It is one dependent variable with one independent variable. So, the independent variable always depends upon the dependent variable. So, y is equal to a plus bx plus lambda. So, this formula should be followed throughout. So, in this example, epsilon is a residual or it's an error. So, it's very simple because one independent variable is depending upon one dependent variable. Now, let's look into multiple linear regression, or it can also be called multiple regression. Okay, so the meaning of multiple linear regression analysis is similar to the linear regression analysis model, wherein only the difference is you have multiple independent variables on a single dependent variable. So, the same methods apply here also, but instead of a single independent variable, you have multiple independent variables. So, the formula becomes y is equal to a plus bx1 plus cx2 plus dx3 plus ex4. Like this you can have any plus epsilon, where epsilon is an error or a residual error. Y dependent variable, x1, x2, x3 being the independent variable, a is an intercept, b, c, d are the various slopes, epsilon is a residual error. So, the only difference what you observe between linear regression with the multiple regression is multiple is a multiple linear regression, wherein you have multiple independent variables which are depending upon a single dependent variable. That's all, nothing else. Now, coming to non-collinearity. Non-collinearity means there should be a minimum correlation with each other. Independent variables should have a minimum correlation with each other. If the independent variables are highly correlated with each other, it will be difficult to access the true relationship. There will be correlation. So it will be very difficult to access the relationship between the dependent and independent variable. Now coming to non-linear regression, that means non-linear regression. There is no proper dependent variable for the independent variables. So what is the problem you get in this case? Prediction becomes very difficult. In this case, future prediction becomes very difficult because the particular regression does not follow any of the criteria, any of the conditions. So if at all it is following any of the conditions, basically other two models are following a linear condition only. Linear condition only, so dependent variable is linearly connected with the independent variable, which will help us in predicting the future points. But in case of non-linear regression, there is no such a future prediction. Based on the plots, whatever we draw, by taking the data from the data sets, we can predict this particular nonlinear regression may use either elliptic or parabolic or any feasible properly definable curve, but there is no hard and fast rule stating that nonlinear regression follows a particular formula. So this is the basic idea about regression analysis. Now let's go to the Python programming for learning linear regression. You can see plots here which are drawn by taking uh, the values on x-axis and values on the y-axis. The moment you observe, actually these are the plots which are drawn by taking some data from the data set, right? So when you think of the data or the plots, whatever are drawn on this particular screen, using some data available in the data set, we can predict that this particular data set is satisfying linear regression analysis. Based on this, there is always a possibility that you can predict any point which is outside this boundary. So tomorrow when you get more data, you can predict it outside the boundary. So why is this used in Python is, in machine learning, this could be one of the tool for predicting the future. Machine learning tools are always used in Python. Machine learning tools are always used for one of the applications which include future prediction. So linear regression is also one important factor which will predict the future based on the currently available data set. Let me give a simple example to prove my discussion. Today you will get a lot of apps, mobile apps, explaining you the weather forecast, explaining you the temperature, humidity and other activities. Or you can think of any other medical field wherein prediction of some seasonal diseases and what is the precaution to be taken to avoid that, and what is the result after applying any precautions as well as treatment. See, these are all some important information to be given to the public by the Department of Health, by the district health officer, DHO. He also can predict by using these kind of machine learning tools. How? By taking the current samples. By taking current samples. So data set here is the current disease samples plus the medical treatment which are given, then what is the resultant of the medical treatment to the patients, and if the same thing continues, what will be the future. So these are all predictions which uses these kind of machine learning tools. Let me give an example. uh, Above example, whatever we see over here, this example, the y-axis represents the speed and x-axis represents the age. Now, why I am telling this? Because see, y axis represents the speed, x axis represents the speed, age. Now the thing comes, what type of regression this is? I can definitely say that this could be an example for linear regression. Why? I will tell you. Here it is given 2, 4, 6, 8, 10, 12, 14, 16. But let me not use this. Say, let me use 20, 40, 60, 80, 100 like this. A person who is at the age of 20, he can walk fastly. But the moment when he goes to 40, his walking speed reduces. When it goes to 60, still it reduces. 80, he may require a walking stick to walk. See, prediction can also be done, right? When a person is walking at the age of 20 to 30, what is the difference which is observed in his walking speed? It's linear in nature. As it passes, as age passes, I can definitely predict at what speed he can walk at the age of 80. So that's a linear regression. Very simple it is. Now, let us draw a plot by taking two axes. I'll take two axes. First axis is the age, second axis is the speed. But in this example, it is given in general. In general, x-axis, one set of data, y-axis is another set of data. The PLT dot scatter is a function which will draw a scatter point, something like this. These are all the points which are drawn by using this above data. Now the question is, this set of data x and y belongs to what type of regression? We have to identify that, right? So here I am using, see, matplotlib, I am using a library file for plotting the graph, and I am using scipy for drawing a line and for the linear regression. SciPy, I'm importing SciPy for drawing the linear regression. So suppose if let me run this example, I will have, right, uh, see, I have used here scatter plot, and this is shown. Then the two lines to make our compiler able to draw this, and let us see how it runs. See, you'll get a plot, something like, we can draw a line over here. It is satisfying. That means the data set containing x and y follows or satisfies linear regression. Okay, so let's see here. Let us import scipy for linear regression. We are importing scipy for an abbreviation status, STATS. So scipy will be used wherever we use STATS, and matplotlib.pyplot as PLT. So PLT always represents matplotlib.pyplot. So here x and y are the data set which we have taken. Then here this is actually uh, taken from SciPy. Because it is satisfying linear regression, we need to mention what is the slope, intercept, x and y intercept, R, P and standard error. R and P and standard error. The previous example I've already mentioned. X, y is equal to ax plus the formula I've given, which is equal to stats dot linear regression of x comma y. So here I am using a function to find out the slope. Then I will draw the plot, scatter points. I will draw the line, then I will show both. So this particular figure is drawn. This particular figure is drawn with the help of plt.scatter, plt.plot of x comma my model. Right? What is my model? My model is a list which contains the map of the slope and linear regression functionalities. So, x and y are the data sets. I'm defining slope, intercept, R, P, standard error from the built-in function linear regression of the data. Then I'm calculating the slope by using a my function. Then I'm using my model for getting the list of it. Then I will draw the points. Then I will draw the line. To draw the line, x is required. And another is a function, my model, which is a list, is required. So the resultant will be the scatter plots as well as the lines. This is how a linear regression program runs. So if I run the example, so you get this. We have data set. We are using these definitions. I am running a function to find out the slope into x, that plus intercept. These are all built in. Then I am defining a list, my model is a list which is taken from map. It's a built-in function with map function and x, which is an axis. So this is used to draw the dots, this is used to draw a line. So plt.show will show it on the screen. So this is how we work with the linear regression. So how does it work? It's given over here. Create arrays that represent the values of x and y. Then execute a method that runs some important key values of linear regression. So first is create an array, create a list for x and y axis. Then execute a method for getting a value for slope, intercept, R, P, standard error. Then you have to create a function that uses a slope as well as intercept to return a new value. The new value will represent where the y-axis for the corresponding x-axis is placed. That means it is used to find out the line. Based on this function, we are calculating the point y based on x. It's a line. So y is equal to mx plus c. So I need to find out the slope and x to find out the new value for y. So that is a list. So that using that list, I can draw the line here. So that's a linear regression.